Lesson number 29, daily summary. In this lesson, we continue multiplying, dividing, adding, and subtracting algebraic fractions. We use the same processes we used in our previous lessons. We refresh our memories on how to add and subtract algebraic fractions. With this example, we'll write our final answer as a single reduced fraction. Okay, let's take a look. I see three fractions all subtracted. So immediately I'm clued in. I need to get a common denominator. It's not multiplication or division. It's addition or subtraction. So common denominator is what we need, and that means factoring all these denominators first. So I'll give myself the structure. I'll actually do it down here. 3 divided by, and I'm going to give myself a big blank space there, and then minus 2 divided by in a big space, and then minus 2 divided by in a big space. Giving yourself appropriate amounts of space can reduce careless errors. So let's take a look at this first denominator, 2x plus 8, trying to factor it completely. Greatest common factor is 2, so we'll factor out a 2, and we're left with x plus 4. And x plus 4 is already reduced as far as possible, so that is factored. Second denominator, 5x minus 15. What is the greatest common factor there? It's a 5. And we're left with an x minus 3. And now that one is factored. And then the last denominator in blue now, x squared plus x minus 12. Greatest common factor is 1. Difference of 2 squares is not in play, so 2 by 2 box is the only other option. Pause the video, see if you can factor that thing with the 2 by 2 box, and come back. Okay, so hopefully we got x plus 4, x minus 3, and now that one is factored completely. Okay, so now looking at our new denominators, we're going to try to fill in what's missing. So looking at the first two denominators only, what is this first denominator missing that the second denominator has? Well, I don't see anything in common, right? Like the second denominator has a 5. This one does not have a 5, so it needs a 5. And the second denominator has x minus 3, which is not the same as x plus 4. So we give this first fraction both 5 and x minus 3, and therefore on the top as well. Don't really need it, but I like putting bags around all of my original numerators. Okay, what's the second denominator missing that the first one has? Well, the first one has a 2 and an x plus 4, and this denominator does not have either of those. So we give this denominator both 2 and x plus 4, and therefore give the numerator the same 2 and x plus 4, and we'll give a bag around that numerator. So now the first two denominators are exactly the same. 2x plus 4, 5x minus 3, 2x plus 4, 5x minus 3. So now we're ready to look at the third denominator. What does the second one need from the third one? Well, the third one has an x plus 4. Hey, got that already. And the third one has an x minus 3. Got that already. So the second one isn't missing anything. So the last thing is to complete the third denominator with whatever the second one has. So the second one has a 5. We need a 5. The second one has an x minus 3, but we don't need that. We've already got it. We've got a 2 here. We need a 2. X plus 4 here. We've got that. So it's really just a 5 and the 2. Top and bottom at the same time. Bag around that one. Okay, and if you look carefully, these three denominators are now exactly the same. We have built the lowest common denominator. Okay, equals. So let's go ahead and, what do we want to do? Let's go ahead and distribute in the individual numerators. So 3 times 5 is 15. In my mind, I'm now going to do this. I'm going to erase this in a second, but it's 15 distributing on the outside of x minus 3. The 3 doesn't also go into the x minus 3. Once you've absorbed the 3 into the 5 and made it 15, there's no more 3 left here to come into the parentheses. So it's just 15 on the outside of x minus 3, which we distribute and get 15x minus 45. Divided by, and then I'm going to write that this denominator right here, but I am going to smush the 2 and the 5 together. I'll shuffle them to the front in my mind and just make it 10, and then x plus 4, x minus 3. Minus, and now we will distribute in this numerator. 2 times 2 is 4, and now I'm going to do a 4 distributing in here. So 4 distributes through the parentheses, get 4x plus 16. Divided by that same denominator, I'll put it in the same order as the first denominator. Minus Okay, and then 2 times 5 times 2, that's just 20, no distributing there. And then the same order for this denominator. Okay, and now that we have the same denominator and the numerators are all as good as they're going to get, let's go ahead and make a single fraction with this one denominator. And now we'll just put all the numerators up on top of a single fraction. 15x minus 45 minus 4x plus 16 minus 20. And we're almost going to get the right answer if we do this problem out, but it's not right because I forgot my bags. Each of these numerators needed to have a bag. And the mistake was from the middle parentheses. This subtraction sign should have applied to this whole numerator, including the 16, but without these parentheses, it would have looked like minus 4x, that's good, but plus 16, that's no good. It was supposed to be minus 16. Okay, let's get rid of the bags now. The first one, not relevant because there's a positive 1 in the front. Second one, that minus sign comes in and changes both signs. Third one, not necessary, but didn't hurt to have it. Okay, now we'll combine like terms upstairs. 15x minus 4x, that's 11x. Now the constants, minus 45, minus 16, minus 20. 61, I think that's 81, minus 81. Yeah, and then we just check to see if we can factor the top and maybe reduce with one of the factors in the bottom. The greatest common factor on top is just 1, and it's not a difference of 2 squares, and it's not a 2 by 2 box. So we're done here. And again, there's no need to ever distribute out on the bottom for these fraction problems. Leave it in factored form. Okay, let's try number 2. All right, taking the broad view here, I see 3 fractions. 1, 2, 3. First operation is multiplication. Second one is division. I'm going to keep the first 2 fractions just like they are. Copy them wholesale. Copy that multiplication as well. Now we're going to make the only change in this first step, and that's to change the division symbol to multiplication and to take that last fraction and flip it over, right? It's reciprocal. So lots of copying, one small change. I guess 2 changes. Division becomes multiplication, last fraction becomes flipped. Okay, I am allowed to multiply straight across top and straight across the bottom, but what I need to do first is factor everything so that I can reduce any common factors. Let's get rid of any foo-foos. So first numerator, 4x minus 12, greatest common factor is 4, left with x minus 3. First denominator, greatest common factor, 9, and also x to the third. Left with x minus 5. That fraction's done. Times 3x to the 7th, nothing to do there. X plus 7, nothing to do there. Okay, x squared plus 2x minus 35. Greatest common factor is 1. Not a difference of 2 squares, but it is 2 by 2 boxable. So pause the video and come back when you've got your 2 factors. Okay, hopefully we got x plus 7, x minus 5. Last denominator, greatest common factor is 7. And then we're left with a 6 minus 2. Sorry, 7 was not the greatest common factor. 14 was the greatest common factor. My bad. 14 goes into 42 3 times and into 14x, just x times. The reason I caught my mistake, I just missed 42 being divisible by 14. That one's not in my wheelhouse, but when I factored 7 out, in the parentheses I had 6 minus 2x. And when I saw the 6 and the 2, I realized that there was another factor of 2 I could have put into both of those. Okay, now that we're factored everywhere, we're looking for carbon copies, top and the bottom. Doesn't matter which fractions they come from. So for example, the x plus 7 here and the x plus 7 here, cross off. That is a foo-foo. Second fraction, third fraction, doesn't make any difference, just any numerator with any denominator. Okay, any other common factors? Yeah, I see x minus 5s. There. Any other common factors? Yes, I see an x to the 7th on top and an x to the 3rd on the bottom. And we know we're supposed to subtract the powers and put the x's where there are more. So there's no x's left here, and there are x to the 4th left up here. Subtracting 7 minus 3. And then there's the numerical factoring, canceling that we should do as well. So for example, 3 and 9 reduce. This becomes a 3 and this becomes a 1. And also the 4 and the 14, both divisible by 2. Okay, so I think we've crossed off everything that's carbon copies and we've taken care of the numerical canceling. And there's one other thing we need to look for, and that was that funny pattern a minus b over b minus a, which reduced to -1. Do we see that funny pattern? Well, let's take a look. I've got x minus 3, 3 minus x. That is the funny pattern. Exactly the same thing in the parentheses, subtraction in both, it's just the reverse order, a minus b over b minus a. And when you have that, you cross them both off, and you replace one of them with a -1. I'd like to put my -1 in the front of the fraction, which I'll do in my final answer. But in this case, I'll just put it on the top. Don't put a -1 in both places, just in one place. Okay, so then I think we're ready to write our final answer with a negative sign in the front. Okay, upstairs, all that's left that isn't crossed off is the 2 and the -1, which we've already put in the front, and then the x to the 4th. So the top is simple, 2x to the 4th. And the bottom, I see a 3 and then a 7. And that's it. And so then I think our final answer here is just -2x to the 4th over 21. And I just want to point out that I made frequent use of color here. You might not have as many, colorful pencils or pens when you're doing these, but you really want to, at the very least, give yourself enough space that you can see what's happening and maybe at least have, one other color besides your standard one so that you can see what's happening when you cross things off. Okay, so just keep in mind the fundamental differences between the addition subtraction problem we did first on this page and then the multiplication division problem we did second. Fundamentally different tasks for those two problems.